right, baby. I'm gonna get streaming.
Hi, baby. I followed up before.
Hmm. You gonna post? All right. Well, that's good, everybody. All right. We're going to continue on. We left off yesterday with configuring this topology. Oh, just trying to get caught up back where I was. All right. So get this over here. So I can use this to turn this down. All right. So let's recap. So yesterday, we started. I started a lab and just got off some basic configurations. Again, a lot of this is to just refresh my memory on a lot of the basic fundamental concepts, and then work my way up to more advanced concepts. Right now, we're just starting back from networking up, and then obviously we'll get into cloud automation and stuff like that. So just to kind of recap where we're at, yesterday I downloaded Cisco Modern Labs. Again, I booted up the server, and I kind of was just creating a general foundational lab, just going over commands and stuff like that. Again, going over some stuff that has to deal with switches, some stuff that has to do with routers and host. So it's kind of where I'm at. We left off yesterday, and I'll go over the configuration. I'll go over the configuration on both the switch and the router real quick to recap where I left off. So let's start there. So, also, I'm going to be doing. Hopefully you guys can see the terminals a little bit better. I'm going to be doing a different way here, and you guys can tell me if you like it and if you can see the actual terminal a little bit better. This is R1, so this is our router right here. Let me just get this out of the way. I'll put this right here. That's fine right there. Perfect. All right, so you can see this is our router terminal here. Hopefully you guys can see that a little bit better. Get into here, and we'll just do some show commands. So show. All right. So just like we were doing yesterday during yesterday's stream. We had created, let me just back up a little bit. We're going through commands, and we were working with the switch here. We created VLANs. We're going to be pretty much supporting these hosts that live on separate VLANs, VLAN 30, 20, and 10. And let's do this real quick so we can go over to the switch so you guys can see the switch configuration. Show. All right, so as you can see here, let me do this. All right, so as you can see on our switch here, we have our VLANs and our interfaces, and we'll go back to the desktop here. You can see our interfaces, so interface 3, interface 2 and 1, and then interface 0 here. And then we have our corresponding VLANs, VLAN 10, 20, 30. And our router over here, back on the over here, is on VLAN 1 here. All right, so it's kind of the gist of it. And again, we're going to be the kind of the network breakdown as we kind of had it yesterday. 192.168.0. Well, this is going to be .30.0/24. And then this one is going to be 192.168.20.0/24. And then VLAN 10 is going to be 192.168.10.0/24. We come over here, and on the router here, 192.168. I believe, yep, that's 1. Yeah, it's 1.0/24. It's that network right there. So again, each VLAN, VLAN 30, VLAN 20, VLAN 10, these could be their corresponding networks. As we went through the lab yesterday, we showed that even if each host technically has the same network address as each other, by being separated over VLAN, they're being broken up off of each, pretty much on their own segmented network there, their own virtual LAN for the most part. And then that's when that's where these virtual interfaces on our interface 0 here on our router come into place here, and that's why we created the virtual interface 10, 20, and 30 to correspond to their VLANs here. And so I think we kind of finished off yesterday with creating the DHCP pools for each one, and we can take a look at that, and we'll do a show DHCP pool. There you go. All right. Let's go back to this. Move that right there. Perfect. All right. Excuse me. All right. So, we did a. Where is it? Right there. We did a DHCP pool. Show show IP DHCP pool command here, and we can take a look at the DHCP pools that we created. We created this VLAN 10, 20, and we'll finish it off. And we have VLAN 30 here, right here. It's given some of the information, IP ranges here. That's our IP range for our network 30 here. So from 1 to 254. We have some, we have leased, and we have the excluded address. Remember, we created the excluded list there. Let's see if we can pull that up too. Let's do a excluded. We'll do all. All right. So there's our list of excluded addresses. So in VLAN 10, we have from 1 to 10 here. A total of 10 addresses. Same here in VLAN 20 and 30 here. So again, the the show commands. Show commands are very useful, very powerful. You can kind of see what you're doing, so you're not getting lost in the weeds. Excuse me. Get lost in the weeds on where you're at or what's going on. Yada yada yada. So, let's take a look here. Let's take a look back at some of the DHCP information here. Just take a look at it. And so it gives us pretty much all the information that we really need. Subnet is currently in this pool. Very good. All right. I don't know what we did with DNS. Let's do a show IP DNS. Let's do a name list real quick. We got nothing there. Primary. Nothing there. We'll do servers. Got nothing there. Servers view. We'll do a view. Okay. What we got? So DNS default parameters, DNS resolver settings, domain name, domain lookup is enabled. Default. All right, so we don't have a default domain name yet. Search. We did identify ourselves as the DNS server. Server settings, forwarding queries is enabled. Forwarding address. Okay. So we're probably see, we're not gonna have a forwarding address, but because it's probably coming off the virtual interface, and we're gonna be sending it to this IP, which is us still. Maybe we still need forwarding queries. Where he forwards it to. ourselves, pretty much. We'll take a look at how that's all gonna work. So let's just write down a couple things, give ourselves a little list of things that we need to do, so we don't forget here. Where's my green? Like my green. Go small. So we need to create a domain name. Domain name. So we need to create a domain name. What else? Forwarding address. We'll see how that affects, if it's going to affect us at all, with that being enabled still. But we need to create name list. Name list so that we can resolve. And what else? All right, that's good for now. I've got a couple things to at least get started with. All right. Let's go back here for a second. I believe we're watching. Yeah, that's where we were at yesterday. Is it going to play? Maybe not. Let's skip to the other one. See if that'll work. There it goes.
In itself to be able to resolve FQDNs. So for example, from the router, maybe you want to ping Linux A from there. Then you would need to set it up as a DNS client. Now, you don't need to set the router up as a DNS client for DNS traffic to pass through it. This is only if you need the router itself to be able to resolve FQDNs to host names. So often we won't do that. Often when we're working on a router, we're all...
Okay, guys, this is Neil Anderson. You guys can check him out on his YouTube page, Flackbox, link in the description. Link is in the description. His Udemy class, same thing with David Bombal too. His YouTube page is linked in the description. Same with his Udemy class. If you guys have any question on where, who you listening to in the background or whatnot, I go back and forth between these two. Each one has, good perspective on it. So.
Always going to be working with IP addresses.
But yeah, so we're watching his video. This video right here is he's going over how to set up DNS on a Cisco router. We're gonna kind of follow along with how he's doing it, and just get a sense on how to set it up, how to make sure it's working properly, and then we'll take a look at the traffic and stuff like that. We'll pull up Wireshark and whatnot. So.
If you did want it to be able to resolve host names, the commands to enter are IP domain lookup to allow it to look up a DNS server, IP name server, and then the IP address of your DNS server, IP domain name, and then the primary domain name. And if you want it to also look up additional DNS suffixes, IP domain list, and then those additional suffixes. Okay, so that's how you configure it to be a DNS client. If you...
Yeah, let me open up this here. We'll take this little paste bin for ourselves. What we got?
wanted a router to be your DNS server, then to configure that, you would enter those same commands plus IPDNS server is a command that configures it as a DNS server, and then you would need to enter address records for everything.
All right, so let's create. Let's come over here. Clean this up. So we got a couple commands we're gonna do. We got IP domain. Is it domain? Yes, domain lookup. IP domain lookup. Now that one, you can shut that down too. That'll prevent you from tying up your command line, trying to look up domain names and stuff like that. We're going to keep that enabled for now because that's kind of what we're having here. So, and then we have IP name server. And we'll just put in IP name server. So that's, I'm pretty sure, if so, let's do this. If you're, we'll change this to Google actually. So we'll do 8.8.8.8 so I know. I'll just put external. Okay. And next we have IP domain name. And that command, this is where you create, so example dot com. Your domain name. And we have an IP domain list command, and that'll be example com additional. Suffixes. All right. And so we'll do this, drop this down. DNS server. Alright, and what we got? We got IP DNS server. And this turns router to DNS server. Okay. And then we have IP host and example .com at 192.168.1. And we'll do this naming hosts. Naming host ads. Okay. So we got a handful of commands here. Pretty self-explanatory. Yeah, so we're pretty good on that. So we have those. So I'll put those aside for now. We'll keep working along here.
That you want it to be able to resolve, the command for that is IP host, and then the host name, and then the IP address of that host. Now, you will not usually want a Cisco router to be a DNS server. Usually you would use an external Windows or Unix or Linux server to do that, but it is capable of doing it. Okay, those were the commands.
Just to touch on one thing, yeah, I mean, so we're labbing that today, because I'm not at the point yet to, you know, I want to take these labs step by step. So eventually we're going to create an external connection here, but we need NAT on the router that we're connecting the external connection to you know, do IP translation and stuff like that, and then we can use probably this Ubuntu host there to you know, finally update and download. I think it's bind and stuff like that. There's a couple of repository DNS programs we can probably, you know, small programs we can download on that, and then, you know, kind of use it that way, and then, you know, just do stuff like that. So, but for now we're going to be still using the router. So, all right, so let's get back to the router here. All right, let's do a what was the better show command that we
Let's configure
were
that in the
doing
lab
here?
next. I'll have a look at the lab topology first. You can see I've got 3 routers, R1, R2, and R3. R1 has got IP address 10.10.10.1. R2 is 10.10.10.2. It's also got an interface of 10.10.20.2, and R3 is at 10.10.20.1. I'm going to configure R3 as the DNS server, and I'm going to configure entries for all 3 routers on there so it will be able to resolve them, and then we'll configure R1 as the DNS client. Okay, so I've got a window open for both routers. Let's configure the DNS server first, which was R3. I'll do a show IP interface brief just to check the IP address is right on there. Yeah, 10.10.20.1. That's going to be our DNS server.
Maybe we should. Well, yeah. Maybe we should step back from that because we still don't. We're not going to have IP addresses for the we're not going to have IP addresses for these hosts just yet until we get DHCP finally squared away. And I believe that is as easy as, gotta come over to the switch next. And I believe we need to, all we're gonna need to do with that, see, to this one we're working on. All right, yeah. All right, so I believe if we do this, we have to change the. Yeah, let's do this. We'll do a show. Show interface. Switch port. Just said that. See what it comes up as. All right. Let me open this up so you guys can see that better. good enough for you guys to see right there. All right, so here is some of the information. This is the interface that's facing the router here, interface 0 here. So we have switch port enabled, active mode, static access, operational, administrating, trunking, negotiating, operational, trunking, native, trunking off. Okay. Trunking native mode. Mission tag enabled. All right. Let's come over here. So, So I'll go to ensure that all hosts and different VLANs can reach the router, especially when the router is connected to VLAN 1 and the router on a stick topology. You need to configure the switch port to the router as a trunk port. The trunk port should allow all relevant VLANs, including VLAN 1, to pass through switch configurations. Alright, so we got a couple things. VLAN all. Switch port, native VLAN 1. Switch port mode sets the switch port mode trunk sets the interface to trunk mode, allowing to carry traffic to multiple VLANs. Switch port trunk allowed VLANs on permits all VLANs to traverse trunk link. Switch port trunk native VLAN 1 specifies for untagged traffic. Okay. Configuration access ports for hosts. Assign each port the appropriate VLAN configuration on each port. Says, yep, okay. So I've already done that. And okay. So get back to the switch here. And we'll come back to, it's actually this interface right here, interface 0. All right, so this is our interface we're going to come back to in a second. So let's get into it. Config T, configuration terminal mode, and then let's enter into that interface. So 0-0, and we're in the interface, and we're going to switch port. Switch port mode trunk. All right, comms rejected interface whose trunk's encapsulation is auto can not be configured to trunk mode. All right. Dude. Okay, so this error message you got a command rejected, yada yada, or occurs because the switch interface is set to automatically negotiate trunk encapsulation, but it requires a specific encapsulation method to be defined before setting the interface to trunk mode. All right, so. All right. So, all right. So that's the problem. So, to resolve this issue, you need to manually specify the trunk encapsulation method. Typical methods is the IEEE 802.1Q. Before configuring this interface as trunk, you should do this. All right. So, and we'll create a paste bin for this too, guys. So, if you're wondering, so we need to do this instead. So we need to specify. So we're going to specify switch port trunk incap dot 1Q. Okay, now that we specified, now we can go back to the switch port mode trunk. Now it's allowed us. We're not getting the same error message here. All right, we're getting some new messages here saying that the line interface yada changed state to down, and now it's changed the state to up. So the interface went down and it went up. All right, so now we're going to, so this is an optional command, but this is again to maybe specify things in a correct way. So you're not just allowing everything, and it's not just floodgates, you're allowing the traffic you want to allowing. So we're going to specify which, so we're going to say switch port, all right, we're going to say trunk allowed, and we're going to say VLAN 1 as our native VLAN, 10, 20, 30. All right. And we're going to specify switch port, trunk, native, and we're going to specify as VLAN 1. All right. Oh, let's do this. Let's exit out of this. Let's just write this to the configuration real quick, and let's do a show VLAN interface. Right, so that. Oh, so it was the show int VLAN. Where's that other command? What was it? There we go. All right, so here's some of our new information here. So we got switch port enabled, administrative mode trunk, operation mode trunk. So it's specifying the .1Q, trunking on default. That. and it's got a list of our VLANs right here. All right, so we have that. I'm curious to know now. Well, let me even this back out. What this was. Let's go back over to the. Let's go back over to the router real quick. So let's do it. What's the show? IP DHCP. I believe it's Pool. Not Tim Pool. Pool. And yeah, so they did give out addresses already. Okay. We'll have to go back to the say that. All right, so looks like we've already leased some addresses, and I'm pretty sure if we go over to our host, let's actually check this though real quick. Erase these stupid things I didn't have my thingy on. Bindings. Is it bindings? Yeah. Okay. Cool. That shows it. Oh, perfect. Perfect. Expand that a little bit more so you guys can see that. All right, so as you can see, we have some addresses that I'm pretty sure once we did the trunking and all that, I probably should have shut off the interface. We can always do it again, but the each host on its respective VLANs, and we'll make sure too. We'll go over the host, check that out. Each host leased an address here from our DHCP server, and you can see on its respected virtual lines here. So we have 0.10, 0.20, and 0.30 for our virtual lines off of our main line there. Okay, cool. So that worked. We got that. All right, show me. Is that on right there? Let's go over to our host. Okay, so this is host one right here. So let's rename the host so that way we're all on the same page with everything. Host name, and we're just gonna name you host one. Okay, That way we can tell. And let's do an ifconfig. If I can spell right, ifconfig. So many G's. All right, so success. We have our. Let's do this. Stop this. My timer, and we have our address. So 192.168.10.11. All right, and we have our broadcast, correct net mask. Let's run this command next. Do a -a. Get a little bit more. Trying to see. Well, we'll find. Looks good though. Looks good for now. We'll go to host 2. We'll do the same thing. So sudo hostname host 2. We'll do an ifconfig, and we have the correct IP address. We do 192.168.20.11. Looks good. Looks good. And this is host 3. We'll do a sudo hostname, and we'll host 3. Okay, ifconfig, and cool. So we have the correct IP address of 192.168.30.11. Perfect. So that all worked out. Let's see if we can ping now. See if we can ping the router first. 192.168.1.1. We'll see if we can ping that router. Then we'll see if we can ping. If we can't ping that, maybe we'll see if we can ping the virtual interface. But we'll see. Yeah, we can. Okay. Okay. So cool. So we can ping the router. All right. Now let's see if we can ping one of the other hosts. So 192.168. Where are we at? We're host 3. We'll do 10.11. And cool. All right. So we've showed. Go back to this screen. All right. Boom. So just like how we have it set up, so we have our 3 separate networks here. So we have our network 30, network 30, network 20, network 10, with their corresponding VLANs that are on each interface with each route. With the switch here, the switch has the corresponding VLANs to correspond with the correct network. Yeah. All right. So cool. That worked. That worked out. That worked out pretty well. Let's look at some. So, yeah, anybody have any questions on any of that? And again, this is pretty much a router. Let me clean this up here. A router on a stick topology here, where you have just erase some of this crap right here. All right, so we have our router, and so this would be like our edge before, you know, the great big internet here. We still will go through. We still gotta do some NAT 2, because mind you, this router currently, yes, this router is routing traffic successfully between these 3 hosts, because this router has some information about where these hosts are located, where to route the traffic to each host, because there's some intelligence here, and then there's also some intelligence here too. We're relying on the intelligence on the switch to then trunk and encapsulate the corresponding traffic through each of the corresponding VLANs and out of the correct interfaces. And also these hosts too can, reply information back and forth to each other through the help of the router here, which it's not so much that the switch, so when these hosts here are trying to communicate with host in the other VLANs, the switch is not going to switch the traffic, because these are on different segments on their own virtual LAN. So it's not like if these hosts were on the same VLAN but just separated by different interfaces, the switch itself would move the traffic around. Because the hosts are living on their own separate LAN, their own separate, their own mine network here, we need a router to route that traffic back and forth to each one here. And doing it with DHCP, the router acting as our DHCP server and supporting the addressing and the traffic, the router itself keeps things in an organized fashion here with the traffic and everything going through. So, all right. Trying to think if there's anything else we can do with DHCP while we're here before we move on to DNS, because I'll move around too quickly. I'll just take a go over here. Yeah. Yeah. Thank you. Says DNS switches. Alright, so let's get into which video is that? Well, we'll go back up to the DNS video. It's one of the last videos I've watched, anyways.
In this lecture, you'll learn about DHCP, the Dynamic Host Configuration Protocol. It's a client-server protocol that automatically provides a host with its IP address and other related configuration information like its subnet mask and default gateway. The DHCP clients obtain their IP configuration information from the server rather than being manually configured. So this can save you a lot of legwork. If you look on my PC here, let's look at how to manually configure an IP address. This is on a Windows host. So in Control Panel, I'll go to the network settings, I'll find my network card, go to the properties, and then the Internet Protocol version 4, so the IPv4 properties. And in here, I can see that it's selected to obtain an IP address automatically. That means that my laptop is currently a DHCP client. If I wanted to manually set an IP address on here, I could choose the other radio button to use the following IP address and manually type in an IP address, subnet mask, default gateway, and DNS server. But I don't want to do that. I want it to automatically receive it from the DHCP server, so I will just cancel out of here. How DHCP works is the client sends a DHCP discover message, which is broadcast traffic. The DHCP server will then reply back with a DHCP offer, but it's not completed yet. The client will then reply back with a DHCP request, and then finally the DHCP server sends a DHCP acknowledgement. At that point, the client will have its IP information, like IP address, etc. So the benefit.
We can actually take a look at that too. Yeah. So we can see that whole Dora cycle here. Let's do this. You know what I should do? Yeah, that's what I should do. That way I don't have to keep on going back and forth to that. Torching you guys like that. Alright, I'm gonna do that then. Just thought about that too. So that way I don't have to keep going. What was I just gonna do? No, this is what I was just gonna do. I was gonna go to host 1. I'm on host 1. Alright, so if we come here and do this, get captcha, and alright, let's go to the switch. We're gonna turn off that interface so we can capture that traffic. Huh, you okay out there? Pretty good size for you guys to see well. Alright, so we're on the switch. We're going to do this. We're going to go into interface -1, and we're going to shut down that interface. Alright, so our interface. So we got our messages here saying that the interface has been shut down. So cool. And if we go back to our host here, and we try to ping 192.168.1.1, nothing. Okay, cool. So let's do this then. Wow, ChatGPT is like breaking today. Streams and everything looking good. Alright, so to release the IP address assigned by the interface. Nice. To renew, request a new DHCP. Nice. Alright, so let's do that then. So let's run a ifconfig without the G. So many G's. Thank you very much, dear. Appreciate you.
You have Joe?
Are you okay?
I gotta stop wearing hoodies.
You cooking at this? Just gonna light yourself
Smell
up. Did you burn yourself a little bit?
No, it's just smidge.
Remember, parents, keep kids away from flammable objects. And to all my baby mamas out there in the world, happy Mother's Day to all my baby mamas. All of them. All of them. I love my kids. All of the kids. There's so many kids. Baby mamas, nah. Alright, so still have our IP address. Let's do this. Let's make sure so this, see if this. C or D. So, yeah, we're going to clear the current IP address we have right now. So we're going to do sudo if, again, I always put that G there for some reason. Sudo zero, to 0.0.0, not mask, 0.0.0.0. Perfect. Okay. run. Config again. And cool, we don't have an IP address anymore. Perfect. Perfect. All right, this is that line coming from there. We're gonna start capturing packets now. Yeah. Let's start capturing packets. And then we're gonna do this. I'm gonna do a no shut. Line will come up. We should have, okay, we got that happening. Go back to host 1. We'll see if we got another IP address. We have not, so we're going to request another IP address, and that's going to be, let's just make sure. Oh, so we're going to do a sudo udhcpc. Okay. And okay. We'll see if we got all those. Okay. Stop. And I think we got a couple pages of records here. Stop. Link. Open up thingy. Okay, we got our packets. Got span and tree. All right, so here we go. So we found it. So we got our little Dora sequence here. So this is our Dora sequence right here. So we have our discovery, offer, request, acknowledgement. So Dora. We'll take a look at that. All right, so this is coming from our host here. So we have our source right here as our host. Remember, we went back and undid our, well, erased and configured it all to zeros, our IP address. And then we have our offer here. Take a look at that. Your client IP address. I'm guessing the router still had a record of the client's MAC address and then reassigned it the same IP address that it just had. And I didn't even confirm that just yet, so let's go back and confirm with host 1 again what its actual IP address is. And yep, so it gave its IP address again at 10.1. And that was some good information though this gave us. We ran the sudo udhcpc command here. So it says, you know, discovering the broadcasting discovery, and again, we could see that here. That's our discovery. So when we ran that command, it's shooting this PDU out of its interface card. Again, even though it doesn't have an IP address, it's still shooting that PDU out and broadcasting for select on server. Okay, lease obtained. Cool. Deleting other routers, adding DNS. Okay. And now let's see. Let's make sure we can still ping 192.168.30.11. All right, and we have connectivity, and we can ping other hosts as we go along. Then we got our offer. Did we go over the request yet? So here's the request. So the request, yes, so this is coming from the host, again, host 1. Yours, next, yep. Service host name's not given. Boot, magic, and then we finally have our acknowledgement. And the acknowledgement again is coming from, where is the acknowledgement coming from? It's coming from the router. It's coming from the router. Cool. Oh, then it's given its, yeah. So it's saying this is your IP address right there. Renew anything. So it's identifying that router. Okay, so this is where we get some of that information too. Okay, so inside of that PDU, there's some of that other information. I always wonder where that. Okay, so we have, it's also sending within this PDU. It's sending the domain name. It's giving it subnet mask. Yep. Okay. Rebind every 21 hours. Renewal. Cloud identifier. Yep. All right. Okay. Cool. Take a look at that. Let's go back here.
Benefits that we get from using DHCP. Well, I just showed you there a minute ago about how we can manually configure an IP address. Imagine if you worked in a large campus where you had 5,000 hosts there. It would obviously be super inconvenient to physically walk around all 5,000 hosts and manually configure them with an IP address. Also, if you did that, it's very likely on some of them you would accidentally make a misconfiguration, like a typo, or accidentally enter some duplicate IP addresses. But using a DHCP server, that gives you centralized and automated IP configuration in that one central location, and you know that you're not going to have any mistakes happening. Much easier than manually assigning an IP address to all your individual hosts. You can also add additional IP configuration values by using DHCP options. For example, if you're using IP phones in your office, they need to learn where their server is. That's their TFTP server. Well, you can give them that information using DHCP. It gives efficient handling of clients that must be updated frequently, such as laptops that move to different locations on a wireless network. In your campus, different physical areas of the network are going to have different IP subnets and different VLANs. It would be really inconvenient if you had to manually change the IP address on your laptop every time you move to a different location in the network. But using DHCP, the laptop will automatically be updated with a correct IP address. And lastly, the forwarding of initial DHCP messages by using a DHCP relay agent eliminates the need for a DHCP server on every subnet. So in a large campus where you do have multiple subnets, you don't need to put a DHCP server on every single one. You'll have one centralized DHCP server, maybe two for redundancy, and they will have different scopes for the different subnets. And whenever a client comes online, it will automatically be given an IP address for the correct subnet. You'll see how that works later on in this section. So we mentioned earlier that you have all of those benefits of it being more convenient using a DHCP server. It also stops you from accidentally putting in a typo or configuring duplicate IP addresses. The kinds of clients that will be DHCP clients. Well, desktop PCs and laptops are good candidates to be DHCP clients because typically you're going to have a lot of those in the office. You don't want to have to manually go and configure them all. Using DHCP saves you having to do that. And your normal desktop PC, it will make outgoing connections to the internet and to other internal hosts, other internal servers in your network, but it's not going to be taking direct incoming connections. You're not running any services on there, so you're never going to have somebody outside it directly connecting to that host. So it doesn't need to have a fixed IP address. It doesn't matter if the IP address changes over time, and that can happen with DHCP. Your servers and network infrastructure devices, on the other hand, like your routers, your switches, and your firewalls, are not good candidates to be DHCP clients. They're mission-critical devices that are required for the running of the network and for its services to function. Their IP addresses are going to be fixed. They have to stay the same because they're going to be accepting incoming connections. So you're
And that's again to let's go back here. And let's do show DHCP. So we have it excluding lists, right? All right, so we have our excluding list. Again, a potential reason in that is to save a range of addresses. If certain equipment would need some kind of static address and not so much a floating almost address. Something like that. So we have our exclusionary list here.
You're going to manually configure them to make sure that they never change, and also you don't want them to be reliant on the DHCP server to be up and running. Okay, so that was an introduction to DHCP. In the next lecture, we'll start talking about what our different options are to actually implement this. In this lecture, you'll learn about the first option for configuring a DHCP server, which is using a Cisco router. You've really got two main options for your DHCP server. You can use a Cisco router, or you can use an external server, which is probably going to be running on Windows, or maybe Linux or Unix. So we'll take a look at the first option here, which is using a Cisco router. If you're going to do this, it's most likely to be a small network, like a branch office, where you don't want to go to the expense of putting in a dedicated server to act as your DHCP server. You're already going to have a Cisco router in that office anyway for doing the routing, so you can also use it as the DHCP server as well, and there's not going to be any additional cost to do that. So we're going to have a look at this in the lab in a second. In our scenario, we've got small branch office, we've got R1 there, which is configured with IP address 10.10.10.1/24 on its fast Ethernet 0/1 interface, and there are...
And for the most part, I mean, a lot of people don't even, I guess take for granted DHCP for the most part. I mean, even in our homes, because of the, the internet service providers, routers, they're pretty much a jack of all trades when it comes to everything for the most part. It's plug and play.
Are DHCP clients on that network, but it's going to give IP addresses too. So we need to configure a DHCP pool for the 10.10.10.0/24 subnet. We've also got a DNS server in the office as well at IP address 10.10.20.10, and we also want to give the client PCs that information as well. So the commands to configure this, first off, we're going to specify our excluded addresses. Typically in a subnet, you might have some hosts there that you're going to want to have a fixed IP address. For example, printers or the router itself, other network infrastructure devices. So usually you're not going to give out every single address in the entire IP subnet for DHCP clients. You're probably going to have a few addresses that are reserved. You'll usually have a reserved addresses either at the start of the scope or at the end of the scope. For example, 1 to 10 or 240 to 254. In our example here, we're going to exclude addresses .1 to .10 from the DHCP scope. And it's a good idea to put this command in first before you configure the DHCP scope, so that way clients won't get them before you exclude them. So the command to do this is a global configuration, IP DHCP excluded address, and then the starting IP address 10.10.10.1 for our example, and then a space, and then the ending address in the range 10.10.10.10. So .1 to .10 will not tell the clients where their default gateway is. And finally, we've said DNS DHCP binding. And here I can see that 10.10.10.11 was given out to the client with MAC address ending D116, and then 10.10.10.12 was given out to the client with MAC address.
Yeah, we can see all that information here. Off of our interfaces here. Well, you guys can't see that far. That's good though. But it has, yeah, let me just expand that a little bit more so you guys can see all of that. So again, we have all of our bindings here for our hosts, their MAC addresses, their leases expire, and we have the interfaces that we can find them. Let's show. On our ARP table here, and what we got for our ARP table here, and we have pretty much all our respective routes pretty much planned out and figured out for the most part, with our pair. You can see our virtual interfaces. Obviously, they're going to have the same MAC addresses as our the interface that it lives on, and so on and so forth. All right, cool. All that looks good. Looks right.
Address ending A359. So you can see it started giving out addresses starting with .11 because we'd excluded .1 to .10. Okay, so that's it. Pretty simple configuration. And for the lab demo, we're going to use that exact scenario again. So we'll configure R1. We'll configure it with a DHCP scope for the 10.10.10.0 subnet. So let's go on to R1. You can see I've already got my interfaces configured there. I'll go to global configuration. I want to exclude the addresses first that I don't want to give out. So that's IP DHCP excluded address 10.10.10.1 to 10.10.10.10. Then I configure my pools.
What do I want to show here? To show that's funny that it's still showing that's what, and that's the reality of what I was saying too, that the switch itself is not going to it's not going to forward any of this traffic. It's not going to route this traffic between the VLANs. It's not the switch's job to do that. Now this switch can do that, but we're not. It's not the reason why we're using the switch. We're using the switch as a switch, not as a router. But as you see though, it's MAC address table. Now, if trying to understand that, and it could because of the VLAN. So let's just this do MAC access group. What's access group? Oh, that's probably to set like access command control list and stuff like that. ALCs, believe. No, something like that. What was I looking for though? So let's do a show. And let's MAC accounting. Let's try that. Nothing. Okay. I believe this thing does ARP too. I know it does CDP messages. And that's possibly how it got the. So no management address. Just trying to see if it's showing me any different information. Any of these, I've changed some stuff. No.
To win it. Do you want to eat? Do you want to smoke? Or are you?
No. Yeah, I can do that. Just give me a minute.
Yeah, dude.
No.
Microphone back up.
All right, guys, we're gonna go. We're gonna continue just a little bit more, and then take a short break. Then we'll get right back to it. All right. We're
So
looking
IP
at
DHCP
DHCP.
pool, I'll call this one demo, and then the network that I want to be assigning address.
Whoa, why did that sound?
This is for 10.10.10.0, 255.255.25.
Whoa. Did I break my freaking headphones?
5.0.
There we
The
go.
default router is this router itself at 10.10.10.1, and I also want to specify the DNS server, which was at 10.10.20.10. Okay, so that's it all configured, and then to verify it, I can do a show IP DHCP pool. Let's see if the clients have taken their IP addresses yet. Looks like they have. 2 of them have been leased. To verify, show IP DHCP binding, and there I can see that my 2 clients have picked up their IP addresses from DHCP. The first one got .11, and the second one got .12. So that's how you configure. In this lecture, you'll learn about how to configure a Cisco router to support an external DHCP server. So you learned in the last lecture, for small branch offices, we'll often configure our Cisco router as a DHCP server to save buying an external router, but in larger offices where we've got several subnets, then typically we'll have an external DHCP server there, maybe 2 of them for redundancy as well. So that's what we've got in the example here. We've got an external DHCP server. We've got the same topology as the last lecture, so I've got R1, and our PCs are in the 10.10.10 subnet, but we're not going to configure a DHCP scope on R1 here. The DHCP requests are going to be served by our DHCP and DNS server, which is at 10.10.20.10. But we've got a problem here. So let's see what the problem is. So PC2 gets powered on, doesn't have an IP address yet. So it's configured as a DHCP client, so it sends out a DHCP request. That is broadcast traffic. It hits the switch, and the switch will forward it out all ports apart from the one it was received on, because it's broadcast traffic. So it will hit PC1, it's not a DHCP server, so it will silently discard the packet, and it will hit R1, and it's not a DHCP server either. The problem is that R1 is a router, and routers by default do not forward broadcast traffic. So R1 will not send that DHCP request out onto the 10.10.20 subnet, so it will never reach the DHCP server, and PC2 will not get an IP address. So that's the problem, and the fix for this is we need to configure R1 to forward DHCP requests. The way we do this is we configure it on the interface which will be receiving the DHCP request. So in our example here, the interface in R1 which is facing the clients is fast0/1. So we go to the configuration for interface fast0/1, and we say IP helper address 10.10.20.10. Now, whenever...
Yeah, so that was a good bring up, what he was just going over. What he was discussing was if we had an external router or DHCP server here, routers don't naturally forward DHCP request, because if they did, you know, they'd be requesting them off of the great big internet. So unless we statically address that, or yeah, I mean, obviously you can do anything, you can configure anything to do it, but what I was saying is unless we statically address that with the, what was the command? I think it's the IP. Yeah, the IP helper address command.
the router receives a DHCP request on that interface, it will forward it to the DHCP server at 10.10.20.10, and now our clients will be able to get IP addresses. So that's how we configure a Cisco router to support an external DHCP server. Let's have a look at actually configuring this in the lab. So I'm running this in Packet Tracer because Packet Tracer supports a DHCP server. If we have a look at the config on our DHCP server, if I go to the services tab on here and choose DHCP, you can see I've configured a DHCP scope for the 10.10.10 network. I've specified the default gateway is at .1 and the DNS server is at 10.10.20.10. And I'm going to give out addresses in that subnet starting with 10.10.10.100 with a /24 subnet mask. So my DHCP server is all set up and configured. If I have a look at the config on the PC, so I've gone into PC1 here, and if I look at the config for its interface, I see that it's configured as a DHCP client. But if I open up a command prompt on here and do ipconfig, you can see that it is not getting a valid IP address. That is because the DHCP request is not reaching the server. So to fix this, I need to go onto the router. I'll go into the command line here, and I want to go to global configuration, and then it's interface fast0/1, the interface facing the clients, and I say IP helper address. Let me just expand this out. So IP helper-address, and my DHCP server is at 10.10.20.10. That's it, all that I need to do. If I now go back onto the PC, and I do an ipconfig/renew, then hopefully it's going to be able to pick up the IP address now, and you can see, yes, it has. It's been given the first address in the scope, valid address 10.10.10.100. It's also received its default gateway and its DNS server. So that's how you configure a Cisco router to support an external DHCP server. In this lecture, you'll learn how to configure and verify the IP settings on...
Sit. I got that. That's PowerShell. It's this Mac. Let's back this up a bit right here.
I can see there is my default route, and there is my default gateway. Okay, so in Mac it was fconfig, mask, etc. This does not actually show me the default gateway, so to get that, what I do is a netstat, and then -R for routes, and N for numerical to see it in IP address format. And hit cards here. To configure it, I click on the settings icon, and then I can see the settings. You'll actually see that I'm running a newer version of Ubuntu Desktop here, which is why ifconfig is not installed by default. I could install that if I wanted to, just by running this command here, but I'll show you what the new command is, and that is IP address show. And in there, I can see there is my IP address, and I can see it's a /24 subnet mask. This doesn't show me my default gateway. To see that, it is IP route show. And there I can see my default gateway is at 192.168.1.1. Okay, so the older command is ifconfig, the newer command's IP address show and IP route show. So that was how to configure and verify.
I was curious about that, so... Let's figure this out. ChatGPT is hurting today. All right, the legacy command. All right, so route dash n is the way to display our route table here. That's what I was looking for. That's all I was looking for was our route table on it, just to see things. Back, then to our router. This is the destination. And mind you, as you can see here, our route tables do not include, make sure you guys can see that. Our route tables do not include any of the networks. So we come here, do the same thing. It's just, it only has its network here. So we come here. Let's do this. All right, so we have our route table here. So our gateway of last resort is not set, obviously, because we are our only gateway right now. We have our networks here. So directly connected. Oh, we have all of our networks.
Your IP settings on Windows.
All right, so we got that. Client. Maybe, let's see here. Let's see here. Oh, we still haven't finished DNS yet, so let's go back up to DNS before. There we go.
In this lecture, you'll learn about the domain name system, DNS. So we're back to the OSI stack.
What's this video right here?
So the commands I'll enter first.
Alright, so I'm gonna leave it there. Let me-
It's not like they're.
Alright guys, I'm gonna take a, I don't know, 20 half-hour break. I'm gonna leave the lab and all that running, so we can get back to it. So if you guys wanna, check back in, give me about a half hour or so, and we'll be alright. Go grab some popcorn, go take a little pee, wipe your nose, give your mother a kiss.
Baby mama.
Don't slap your baby mamas. Alright. Alright, y'all. I'll see you back in a little bit. Peace.